All right, looks like we're recording. Let's give this one a try. This is a fun little route optimization lesson that we can teach and work with the students, especially on the day of logistics management. And when we get into the full logistics course, the SEM 3468, we'll do this a couple of different times with different items. His brother Ward was with us for a few years. He worked for M&M's. M&M's, he has a great example out there. Just for fun, you can start it off with this little bit of a video if you really want to. It's talking about a new M&M line that is coming through the manufacturing facility in Cleveland, Tennessee. And maybe show that for just a second. Those are actually Twix, not M&M's. The left, right. Anyway, just a quick, fun little look into another manufacturing or operation facility. With that, we can go out to the modules, in-class activities, and go down to one of the bottom ones here, the M&M transportation. You're going to have the students open this up. You're really going to want to download it. Once you open up the file, what you're going to be giving them is a little scenario. One second here. In this scenario, what we're looking at is the 4 different facilities that are manufacturing M&Ms in the United States. It's not just all taking place in Tennessee, but there's also New Jersey, Texas, and Kansas. That's where M&Ms are being produced, and they're being produced by the tons. All those M&Ms are going to be distributed to stores throughout the world, but they're going to go out of distribution centers. So there's some major regional distribution centers, one in Pennsylvania, Georgia, Texas, California, and Illinois. Obviously, to ship a truck from New Jersey to Illinois is going to cost different than shipping a truck from New Jersey out to California. What we have here is a few different things. First, we've got our supply, our source of supply up here on the top part. And we've got our demand for each of the facilities. And we've got a little chart that tells us what the cost is per each truckload from one facility to another. So to ship from Cleveland, Tennessee to Kennesaw, Georgia, that's pretty close. That's only going to cost $500 per truck. To ship from Cleveland all the way out to California, obviously, is going to be a few more miles, and that's going to cost a lot more money, $2,400. So our job, or the student's job with this project, is to try to optimize the route. We call this route optimization within logistics management. This is a real job. People have this. They do this planning, and they can save the company a lot of money, or they can lose a lot of money. And we'll kind of demonstrate that with this particular project. The way I like to do this is first just get everything set up. So I'll run the students through a quick way of doing that. We've already got transportation costs here. Whoops. I accidentally paused it. I think we're back on track. Transportation costs, I'm going to go ahead and just bold that. I'm going to highlight this whole little table of costs. I'm going to use this as my format for everything else going forward. Paste it down here, but this one let's call allocation table. And actually, since I'm going to be allocating here, I'm going to highlight this a little bit different color. It's just kind of my personal preference. I'm going to change the font all to black, and I'm going to delete everything in here. This is where I'm actually going to allocate which supply goes to which demand. This is going to be my working section. Everything else in here is going to be formulas. Let's take this transportation cost table one more time. Paste it right down here below. This time we're going to call this our total landed cost table. This is where the costs are going to really play out. Once again, you're going to want to delete everything in there. At this point, we can go ahead and do some of the math right up front. Let's do the math here of how much our total landed cost is going to be. The only real trick to this is paying attention to how many tons can fit inside one particular truck. So to do our costs, we're simply going to equal how many tons we allocate. You see, by doing this in the Hackettstown to Hazleton box, also here, Hackettstown to Hazleton, when I do the cost, I'm going to do the you got it, one to the other. Let's actually do this by starting off with a little parenthesis. We're going to come up here, take how much we're allocating, and we're going to divide that by the tons per truck. And I'm going to anchor in that tons per truck just to make sure I can drag this formula all I want. Close that parenthesis. Now I've got how many truckloads I need to meet that ton, so I can times that by cost per truck for that particular destination. If you did that right, you should be able to turn this whole thing to $1, get rid of the change, drag it over, drag it down. Shrink my screen slightly. I've got the math done. Let's just show that it actually works. Let's say that we want to meet the 5,000 demand from Waco, Texas, shipping from, well, we can't take it all from Waco, but let's go ahead and say we'll do it from Cleveland for some crazy odd reason, because Cleveland's got 16,000 units. So if I come down here and I allocate from Cleveland to Texas 5,000 units, I start to get my cost down here in this table. Let's add on to this a little bit more. Let's do some totals. Let's sum up how much transportation we're going to be spending for Hazleton, Pennsylvania deliveries. Drag that over. Let's do the same thing for how much demand we're actually allocating, and let's just sum up each of these rows. Drag those down. What this ultimately allows us to do is to highlight this little box down here in a nice bright green or whatever color we want. That's going to be our total landed cost at the end of the day. Our job is to minimize that cost, keep it as low as possible, and yet still meet all this demand. In order to truly use this allocation table, let's add a few more things. Let's do this right here. Actually, let's start up here. Oh, we'll go down here. That's a good idea. I'm just going to sum up everything here as well. So this is summing up all of the allocation that goes to Hazleton. I can drag that over. I can also sum up everything that is leaving Hackettstown. And I can drag that down. I'm going to go ahead and call this total allocated. I want a different color. I'm going to highlight it in, let's say, orangish. Over here is my total demand met. I'm going to highlight all of that, same color. Now I can play around with this. This can help me out with my allocation process. To help out with that even a little bit more, I'm going to add two more. Up here, I'm going to call this one my balance. How much supply balance do I still have? All that's going to be is my original product minus everything coming from that same location over here. And I should be able to drag that down. Right now, all those numbers match up except for my 5,000 units that was allocated. You can see it was 16, now it's 11 because it's subtracting those 5. Get rid of that 5. Everything is back to normal. I'm going to go ahead and highlight that also in my same color, but I'm going to make it red just because I know that that's something I want to watch. I can't ever go below 0. If I go below 0, I'm allocating product that no longer exists. Let's do another one down here. Let's call this our balance of demand. Similar concept. We're just going to take how much demand we have minus how much demand has been allocated for that particular location. We should be able to drag that one over. Since that's another area where I might have a constraint, I'm going to highlight it, make it red. At the end of the day, I want all those balances to be 0 because I have to meet that demand. I might have some leftover supply, but I can't have leftover demand. I have to meet all my demand. We've created our tool. We are now ready. We can now start allocating. The way I have the students do this first is try to do it manually. Come down here and just try to allocate the different demand in a way that you minimize the cost. You can come down, let's say we need 8,000 for Hazleton, Pennsylvania. I've got all these different places that inventory can come from. I'm going to say that New Jersey is close to Pennsylvania, so I'm just going to give all 8,000 of it from New Jersey. You can see that my Pennsylvania drops to 0. I don't need to allocate anything else there because I'm at a 0 now. I could move along over to my Georgia, and I could keep doing this, and I could throw numbers in here in one way or another. Really, if you want to give the students a hint, you're going to tell them that the rule of thumb, if you ever have to do this manually, is to follow low cost. Start with the lowest cost and work your way up. Let's show this. I'll show you for the first couple. I highlight this whole field of cost. Where is my cheapest cost, my lowest truck? It's right here at $250. That's how much it costs to ship from the Waco, Texas manufacturing site to the Waco, Texas distribution site. $250. Waco needs 5,000 units. Waco has 4,000 units available. So I'm going to come down here to my allocation from Waco to Waco. I'm going to give all 4,000 units because that's my lowest possible cost. When I do that, you can see that I still need another 1,000 for Waco. I don't have any more product coming out of Waco. So I'm going to have to meet that somewhere else. Following my low cost rule, I'm actually going to look at this whole table and see that my next lowest cost is from Cleveland to Kennesaw. Kennesaw needs 10,000 tons. Cleveland has 16,000 tons, so I can meet all of that. So I come down to my allocation table, then 10,000. That balance drops to 0. I still have another 6,000 sitting at Cleveland if I need them. Let's look at our next lowest cost, $600 over here in New Jersey to Pennsylvania. Looks like Pennsylvania needs 8,000. Looks like New Jersey has 13,000. Let's go ahead and do it. At this point, I'd probably turn it over to the students. I would say, keep going. Do what you can do. Let's see who can manually allocate this the best. I would come down. I would continue to meet this demand just kind of randomly. I need another 1,000 units here. I've got 1,000 up here, so I'm going to go ahead and give it to them. 4,000 units over here. I've got, there's 4,000 from New Jersey. Let's just go ahead and do that. That's nice and easy. Illinois, I need 9,000. I've got 6 and 6. Let's go ahead and give them 4,500 from one, 4,500 from the other. Obviously, I wasn't following that rule of thumb anymore of lowest cost. Instead, I was doing what a lot of people might do in the spur of the moment. Just quickly allocate demand and not worry too much about it. Look at my total landed cost, $1.6 million. Is that the best I can do? Who knows? Now we compare, we see what the students come in with. Some of them might come in with lower, some might come in with higher. I'm guessing they're probably going to come in with stuff right around the $1.54 million range or something like that. Whatever they come in with, if you really want to test it out, you can take this one step further and you can use Solver. Solver's always a fun one to use. I use Solver. I like to just quickly clear out demand that's already there in my allocation table and start from scratch. We'll run you through one quick solver so you can share this with the students if you like, or you can run them through it however you want to do it. Of course, we come up to data solver. Anytime we use solver, we're trying to decide, are we minimizing, maximizing? What are we trying to do? In this particular example of route optimization, we want to keep our costs as low as possible. So our goal is going to be this total landed cost down here, and we want to minimize it. The way we're going to minimize that is by allocating demand. So we highlight all of our cells for the allocated demand. But we need certain constraints in place. And we've already set this up where our constraints are readily available. In fact, our only real constraints are already sitting up here in red. So let's go ahead and add them. First constraint, I'm just going to take all my balances and say that those balances have to be greater than or equal to 0. Right? I can't allocate more than what I have. So those have to be 0 or greater. Let's add another one. Let's take our other red area. All of my actual demand, that has to be 0. I can't miss demand. I need to make sure that's there. Only other rule I really need to add, if I hit OK, I can see already that none of my variable cells can be negative. So I don't have to worry about making those all positive. What I might want to do is make sure that they are integers. Otherwise, we're going to have some decimal places, and we can't really have a partial truck because these costs are all based on full truckloads. So let's add one more rule. Let's take everything that we're going to be dealing with, and let's just make sure that they are all integers. It's as simple as that. This is an easy little solver. Solve, and let's see what the magic does. You can see the allocation going on down here in the left-hand corner. It's trying all the different options. Comes up with a solution. We hit OK. We can get this thing down to $1.5 million. Even if I did it manually and had the 154, that's still a $30,000 difference. If you remember my first number, I was up at the 1.6 million. That's over $100,000 difference that we can save that can go straight to the bottom line of the company simply by how we optimize our route, how we send our trucks out. Hopefully that's enough for you to kind of realize or get an idea of a good way to teach this little one and walk the students through it.